Today we'll in the series of TOC lecture we'll see uh, in depth about the machine construction, mathematical model construction. So these are the basics of that mathematical model construction. The thing is that in TOC you are going to model a machine mathematically, and you will be studying about that machine, what are all the theories about the machine, and what is the capability, what are all the whatever you have designed, what is the capability of that particular machine, and then you will also be learning about limitations of that particular machine. Okay, so now what is the basics here in TOC? Symbol is the main basic thing. Okay, it is like a basic building block of, it is a basic building block of TOC. So okay, so what is meant by symbol? So for example, the examples are, say it includes any alphabets. Okay, it may be alphabets, or it may be either 0 or 1, 2. I mean it may be alphabets, English alphabet, or it may be numbers, okay, digits, or even it can be a man or woman. Okay, so it can be anything. Okay, or it can be dot, or it can be star, anything. Okay, so everything is termed as a symbol in here in TOC. Okay, so symbol is the basic building block of TOC, and next from the symbol you are just forming the alphabet, so which is represented as sigma. So this is like alphabet is represented as sigma. So what is the alphabet? So you can take, when I say sigma, so this will be the input alphabet, input set for the given model. Okay, so you are going to give the input from the given alphabet. So the alphabet set contains the symbols. Okay, it may be alphabets, again English alphabets, or even it can be zeros and ones. Okay, or even it can be dot, star, anything. Okay, so this is called input alphabet set. Okay, so symbol is a basic building block of TOC, and from that symbol you are just deriving alphabet. This alphabet contains the symbols, set of symbols, or it can be anything. The symbols can be anything, A comma B comma C, or anything else, or it can be in numbers, or it can be in dot, comma, colon, or anything else. Okay, so this is what alphabet. String is a collection of symbols from the alphabets. Okay, collection of symbols from the alphabets. Okay, so now we'll see the example. So string. So for a string, just I can have A as a string. I can name this A as a string, or A as a string. So if I have this alphabet, okay, this input alphabet set, this may be a string. This A may be a string, or B may be a string, or even A is a string, or even B a string. So likewise you can just take the collection of symbols from the given input alphabet, that is called string. So we are just deriving the string from the set alphabet. Okay, input alphabet. So now just we have one more question here. How many strings of length 2 are possible over the alphabet sigma A comma B? Okay, so just read out the question. How many strings of length 2? Okay, you have to form these strings. Okay, they are asking the count. How many strings of length 2 are possible over the alphabet A comma B? So the input alphabet contains two elements. Okay, that is A and B. Okay, so now you have to form the string in such a way that the string length should be 2. Okay, the length of the string is 2. Okay, so how many in such kind of things, such kind of strings, how many strings you can able to form it? That is the question. So now you just you have two elements, right? The set will be like, you can have, first you just take first element, that is A. So the string length should be A 2, right? Length should be 2. So I'm just making it as A as a one string. Okay, this may be possible. Okay, A can be a one string, and then I'm just making AB. Okay, just combining AB. This can be one string because the length should be 2, right? So I can have AB, or I can have BA. Okay, I can have in the reverse order, that is BA, or even I can have BB. Okay, other than these things, whether I can able to form any other string with the length of 2, just check it. So you have only 2 elements in the alphabet set sigma, that is A comma B. We have to form the strings of the length 2. Okay, we have to find out the number of, how many number of strings can be possible over the alphabet A comma B with the length 2. Okay, so I can able to form only these 4, right? I cannot have A or I cannot have B, because if I say A, which means the length of the string is 1, right? So this will not be a member of the set. So only I will be having only 4 things, right? So I'm just writing it. The answer is like, answer is how many? 4 will be a answer, right? So now you just have one more question. How many strings of length 2 are possible over the alphabet A comma B comma C? They have given one more element here. So in this set sigma, you have 3 elements, A comma B comma C. You have to form these strings with the length 2, okay, from the given alphabet. So I'm just forming here. First I'm taking element A. So I'm just having 3 A's. I may have 3 A's, right? I may have 3 A's. I may have 3 B's, or I may have 3 C's, right? So whether I can have 3 A's, 3 B's, 3 C's? No, just check the length of the string. No, this is not possible, right? This is wrong actually. This is, the length of the string is 3, right? So you cannot have as a member. So they are asking to write a string with length 2, right? So I can have only AA, right? I can have only BB, CC. These are possible from the set ABC. Rather than that, I can have a combination, right? First I can have AB, and I'm just making it as reverse order BA, and then I'm just taking these 2. So BC can be possible, okay, or otherwise I can have CB, okay, and then I'm just making this AC. So AC or CA, okay. Other than these things, these elements, whether I can add any other to the set, just think of it. They are asking to know the count, that is how many number of strings of length 2 are possible over the alphabet A comma B comma C. Okay, so just to count it, you cannot have any other element other than this. So you have 1 2 3 4 5 6 7 8 9, right? 9, right? So the answer is 9. Okay, so now here I'm just making this 4 as a 2 part 2. Okay, this is 2 part 2. This 9 is like 3 part 2. Okay, 3 square becomes 9, right? So 2 square becomes 4, right? So here when I have 2 symbols on the input alphabet, I'm just making 2 part 2. When I have 3 symbols in the input alphabet, I'm making 3 part 2. Okay, right? So this 2 is like number of, whenever you are forming, the length of the string is 2, right? Here 2. So just to see the question here, how many strings of length n are possible over the alphabet A comma B? Just answer this one. Okay, just think, if you understood this question, you can able to answer this question. If you know the answer, just put it in the comment box. Okay, the answer is like, how many strings of length n are possible over the alphabet sigma A comma B? The thing is that I've already said 2 is, this 2 represent what? This 2 represent the number of elements present in the input alphabet set. Okay, so these three represent the number of elements present in the input alphabet, right? So now here, how many alphabets are there? How many members are there in the input alphabet? 2, right? So I will be writing 2. Okay, I'll be writing 2, and length is like, here this represent length, right? So I'm just making it as 2 per n. This is the answer for this question, but so in different way, I'm just making it as length n. So you have to form the string of length n, right? So the string length will be like 1 to n, right? So the 1 to n, 1 2 3 4 5, like that it will end up with n, right? The length of the string is n. So what is the alphabet? The possible alphabet for this one is A comma B. Likewise for this one you will have A comma B. For this one you will have A comma B, right? You have two possibility, right? First place maybe either A or B. Then the second place in the second place again you can have either A or B. Likewise it goes up to N, right? So now you have two possibility here. You have two possibility here. You have two possibilities up to N, right? So I can make it as 2 power N, right? 2 power N. So if I say 5 times 2, right? So which means 2 power 5, right? 2 into 2 into 2 into up to 5 times you will be writing the 2. So multiplying it, so I can make it as 2 power 5. So that is what 2 power N. That is how you are getting the answer as 2 power N. Okay. How many strings of length N are possible over the alphabet sigma A comma B? The answer is 2 power N. If I give, like, I'm just changing the question. So how many strings of length N are possible over the alphabet sigma equals A comma B comma C? What will be the answer? Just give the answer in the comment box below. Okay, I will also remind in the next lecture. Okay, the answer I will be giving in the next lecture. This is one note. Okay, from this question you have got this one, which means how many strings of length N are possible over the alphabet A comma B sigma A comma B is 2 power N. So the second one is, if the number of symbols in sigma is represented by square bracket sigma, then the number of strings of length N possible over sigma is what? So just go through the concepts till now we have gone through and try to answer this one. If the number of symbols in sigma is represented by square bracket sigma, then the number of strings of length N possible over sigma is what they are asking. Okay, so how we were framing before that? So we were taking like how many, this 2 represents number of elements in the alphabet, right? In the alphabet set, input alphabet set. This N represents the length, right? So here what is the number of symbols represented by? This is the representation, right? So I am just making this sigma, mod sigma. So what is the length of the string? N is the length. So this is what the answer. Okay, this is how you have to come up. Okay, so I hope you understood the concepts in this lecture, whatever I have given. Okay, so I'll revise one more thing. Symbol is a basic building block of TOC. The symbol may be anything, A comma B, that is input English alphabet, or it may be numbers 0 to 9 or 0, anything, you can have anything, and it may be any symbol, right? Dot, colon, comma, anything. Okay, this is what symbol, and we are deriving alphabet from the symbol, so that is denoted by the symbol sigma. The sigma is the elements, the combination of symbols here, given here. So you can have any symbols here, set of elements from the symbol. Okay, so A comma B, or you can have 0 1 2 3 as the input alphabet, or you can have dot comma star. This is what alphabet. This alphabet will be the input set for the whichever model we are creating. Okay, so string is the input which is derived from the alphabet set in sigma. It is a collection of symbols from the alphabet. So I can have, when I take this sigma input alphabet, I can have A, B. These are all the strings I can able to form it. Okay, so now we were discussed about how many strings of length 2 are possible over the alphabet sigma. We have given two kinds of sigma. Okay, the first sigma have the set of two elements. Two elements are the present in the sigma. First, number 1. Number 2, which has 3 elements. Okay, so when I say 2, the answer is 2 power 2. When I say 3 input alphabets, 3 power 2. This 2 represents the length, string length, and then from this we are deriving that how many strings of length N are possible over the alphabet sigma A comma B. So this is the number of elements in the set sigma. So that is 2. So therefore length is N. So 2 power N will be the answer. And if the number of symbol is sigma is represented by mod of sigma, then the number of strings of length n possible over sigma is sigma per n, right? So this is the count. Okay, I hope you know what is the meaning of this. This is the number of elements, the length of the what, the symbols present in the set sigma, that is denoted by square bracket, right? The length is represented in n, so the answer is like sigma per mod sigma per n. Okay, this is the today's lecture. This is the basics. So you learned what is symbol, what is alphabet, what is string, right? Till now you have learned 3 things. In the next lecture we will see what is language. Okay, I hope you understood what are all things we have discussed. If you have any doubts, please put in the comment box. Okay, I'll be responding. Okay, thank you. We'll be discussing other things in the later lectures. Thank you.